Everyone, and welcome to this eighth webinar in our data-centric AI series here at the Open Data Institute. Today we have a very special guest, Pierre-Carl Langlais, who's the co-founder of Playas, and who is going to tell you about how to design small language models that are optimized for regulated industries. But before we start, let me just quickly go through these housekeeping rules. So as you might have spotted when you logged into Zoom today, we're recording the webinar and we are going to share it on social media and on various other channels, which are listed here. And we also want to take the opportunity to promote the amazing content conversations that we have on this platform. So we will use quotes and other snippets from the recording in our campaigns. If you like to ask a question, do add it to the Q&A section throughout this 1 hour webinar, and we'll do our best to answer it a bit later once the presentation has finished. And then there's also our team at our back office at the ODI who are around, Neil, Joe, and Matt, and are available in the chat for any other types of queries you may have throughout. So I said at the beginning, this is our 8th webinar in the series. We had 7 amazing speakers so far coming from different areas in data-centric AI, some of them researchers in the corporate world, some of them working for civic society and non-profit like Wikimedia Foundations, some with the legal, some with the technical, some with an ethical background. So if you scan this QR code, you can see all of them and you can watch all the recordings. Today, as I was saying earlier, we are here with Pierre-Carl Langlais, founder of Playas. A few words about himself. He received a PhD in Information and Communication from the Sorbonne, and he was awarded the Young Researcher 2016 Award of the French Society for Information and Communication Science. He's a major figure in the AI space, in responsible AI and data-centric AI, among others, at the AI Action Summit in Paris. So he's going to tell us all about the work that Playas and the team have been doing recently to at least this is my reading, address and redress some major imbalances in the AI ecosystem, and to allow all organizations, especially those in regulated industries, to be able to make the most out of this very, very innovative technology. Following the presentation, as I said, there will be an opportunity to ask questions. And with that, I will hand over to Pierre. Thanks again for being here and for accepting our invitations. And we look forward to your presentation and the discussion afterwards.
Thanks a lot, and thanks a lot, Elena, for the presentation, and everyone for the invitation. I'm really honored to be there, and definitely also since a lot of our visions is very much aligned with what you have, what you're pursuing. So yes, presentation will be about optimizing AI for sensitive industries, and I think it's a bit broader than that because it's also about thinking. Well, personally, I have a lot of commitments also with openness beyond AI. So I've been a Wikipedia admin for a very long time. We're also a contributor to Wikidata. And one of my obsessions also is how we can create also any kind of business incentives to better support the work we can do in terms of open data, in terms of open AI. And seeing also, and actually seeing the fact that many actually industries, and especially in the regulated space, do have incentives to move in this direction for better transparency, for better adherence to the kind of standards they think it's going to be important. So yeah, it's also going to be a presentation about that. So I'm going to open it in wider. Okay, let's say like this. Okay. So yes, just going maybe to talk very briefly about Playas because we are still relatively new. We've been created 1 year ago. And yes, we are a Paris-based startup, and so we are in the commercial space. But our core idea right now is really about solving the key high scalability challenge for sensitive industries. So also as a background, we have been in applied AI for some time. We worked especially with French government for that project called Albert, which were kind of their big copilot program for AI. And one of the key striking thing, which is a bit different, I think, from what they did in the United Kingdom, is that they wanted immediately to use self-hosted open weights model, which are going to host and they are going to fine-tune them. So I took care of this fine-tuning. But regardless, we saw always the same kind of issues. So data quality, lack of efficiency, and especially security risk and questions about regulations, even more coming up now that there is the AI Act. So you need to know exactly what is inside these models. So yeah, that's the core idea of our general vision. It's about, okay, we think there are issues which are commercial in nature, which can be solved by more openness, and which can also in turn better support the kind of open ecosystems we are extremely attached to. So in terms of positioning, we have just made a strategic partnership with Wikimedia Enterprise. We are also very close to Mozilla and the Alliance. And the most important thing, I'm going to talk again about it, so I'm going to stress it, we release this thing called Common Corpus, which is the largest fully open corpus for training, but more on this later. The key part of my presentation is going to be really in three parts. It's going to be about open data, it's going to be about factual data, and it's going to be about semantic data. In all of these cases, it's going to be both a data issue, which is currently unsolved by the kind of existing models, and also a range of potential new forms of models that can be developed, that can be trained, and that can also involve the larger ecosystem. And I think it's really critical. Training AI is mostly about data, really. Even the code part of the infrastructure we had haven't changed that much since transformers, since BERT model. We are just scaling them up, basically. What has changed a lot is the way we're processing the data. We're making it better. We can enrich them. We can create synthetic data on top. We can process it. We can use a larger diversity of sources, more multilinguality. That's what has been one of the main source of progress for AI until now, but it's also an opaque source of progress, which I'm going to stress just afterwards. So let's start with open data, which I think is going to be the most, maybe the most strident data issue that there is right now. The key thing really is that these models are kind of data hungry. So there are large language models, but there is also this thing which is known as chinchilla laws, which is basically meaning that if you want to get a very good models, you can either get a lot of parameters, but it's not great because then afterwards for deployment, it's a lot of cost, or you can get a lot of data. So right now, what is happening is that even the smallest models, they are being trained on a lot of data. Even the llama, the small models are being trained on something like 15 trillion tokens. So to give you a better idea about this size, all of Wikipedia in English is about 5 billion tokens. So all of it, everything, encyclopedic knowledge and so on. So we're talking about something which is more like 3,000 times this size. So obviously when you get into this size range, it raises questions about how do you get the data. And right now, the solutions being used by existing labs are kind of suboptimal for multiple reasons. The first one, which is the one being publicized using web archives, which is kind of actually a way of detuning them because they're not meant to be used for commercial purposes. They are meant to be saved for posterity and so on. And that would create actual issues for even Common Crawl, archive.org, and so on. Actually, there are institutions which have very, very few means. And I know, for instance, Common Crawl is not even archiving PDFs because they have no way to host that. And yet, it's like the XKCD script where you know that there is the open source ecosystem, which is a very small thing that is sustaining this gigantic thing. So you got all these large companies with immense amount of wealth. We are still reliant on very small teams working on archiving. The issue with web archives is mostly the fact you cannot really filter out many of those issues you're going to meet into that. That's what they're doing right now. So they're going to detoxify stuff, they're going to remove stuff which can be problematic from privacy reasons. It's still impossible at this scale. And now it raises really issue of data poisoning. And one of the striking examples that there is right now is even discussion about DeepSeek. We know that is a China-aligned model, which is an open weight, but then can you use that in sensitive applications without really knowing on what kind of alignment has been done? That's the first thing. And then there is the other issue, which is now much more visible now, thanks to a series of trials. So there is a big meta trial right now in the US. They are training on pirated content. And now it creates another issue of liability because it's not just about, okay, it's content accessible online, which is fine almost from the perspective of the text mining exception in Europe. You can train models on the content so long as you have a legitimate access to it. That's not what they're doing. They're training straight on libgen, they're training straight on shadow libraries like NS Archive. So it creates a lot of risk afterwards, and it has a lot of consequences. The main one is the fact that even though data is the most important part of AI models, we don't talk about the data. All the data section you're going to find in these papers from big labs, it's extremely short. It's going to say, okay, we train on the internet plus maybe some books, we don't know. That's the end of the story. Even though data is really critical, even when you think in terms of features of these models, we don't know, for instance, the language distributions. We don't know whether they're trained on PDFs, maybe, and then they can be used in production for that. It's a big issue. So yeah, the main issue right now that there is now on the side of regulated industry, but it goes a bit beyond that, is the fact that right now deployers of models are fully liable. If you read the AI Act, that's a key thing. So if you use an open weights model and whatever is going to output, it's your responsibility, not the model creator. So it creates a range of issues, like, for instance, you can't guarantee it won't going to output copyrighted content. That's been proven to be the case. So this is the issue. This is a study I've mentioned by Patronosai. So they use starting of books, and then afterwards the model is continuing them. It has memorized them, especially a big issue with larger models. I already mentioned DeepSeek. You cannot be sure the alignment is going to fit your regulation expected norms because you don't know even the alignment dataset what they have been used for. And yeah, I think one of the largest issue also is the fact we don't have a vision of model as a product right now. We don't know exactly the features that are inside and whether or not they're going to fit the purpose for what you're going to be making, maybe a fine tuning or just a deployment. And the fact, again, that for instance, a lot of people are expecting to use this model for long context, but the reality is that most of the archives are really small, so less than 300 words. So right now, the main issue also with copyright issue is the fact that alternatives doing it done in the open, they are much more precarious than whatever big labs are currently doing, which is not communicating at all about the data. So a big example, for instance, is the pile, which was one of the main attempts at reproducing what big labs are doing, which is done by a user. And it contained obviously content which were under copyright. And what happened is that obviously publishers looked into that, found the content, asked for removal, and there was even big trial and everything. So for a later, it has been very complicated. I think it's a major issue in Europe because right now we have text mining exception with covers training potentially, but you have still to ensure that, okay, maybe you need to apply your opt-out for publisher and so on. So there's a big discussion right now over the AI Act to know what kind of granularity or information you're going to bring to publishers and everything like this. But okay, that's one thing. Now it's not going to be covering releasability, which is really a key thing if you want really people to audit your models, to really see inside what kind of text has been used, what kind of language has been used, which I think is definitely the best way if we want to really build models that are going to be auditable, especially for regulated sectors. So right now, what is happening is that all the open everything models that exist, and they do exist, we can think of models like Olmo, for instance, from NNI, and a few others, they take advantage of the fact that Hugging Face is being hosted in the US, so it's under fair use, and potentially they can do that. But obviously, it's not a great way to really build an open infrastructure. You need to have some more legal certainty. So that's what we try to do with Common Corpus, which is right now the largest collection of fully open and releasable text. So what it is concretely, it's a series of content which contain provenance and licensing attributions. This is a license column you're seeing right now for about 500 million distinct documents, which are about 2 trillion tokens for that text, at least fortunately. So yeah, it's big. And it starts to get into comparable size to what we are seeing in the big labs in terms of what they are using for training the model. And yeah, it's also showing that we do have enough open content. And even a small labs, because we are really small, we are 10 people in 1 year, could assemble a content with a full-scale provenance detailed information for all the metadata. We even have the links to the original text for many of these texts. We can build that. And we can show it's feasible right in the context of the AI Act, where there was a discussion about what is going to be the granularity of the information that are going to be released. So Right now, common corpus, so it has grown to become a kind of reference training data set beyond what we have trained on this. So we have trained model on this. I'm going to talk afterwards about that, but it's going to be used by 7 different LLMs in Europe and beyond, including 70 billion parameters. So we start to get into the larger range. So how it was created, this thing called common corpus. So it was made thanks to open data, fundamentally. All the big open data programs being made throughout all the past years. And especially I'm thinking about, for instance, in cultural heritage, we have this movement of collection as data, where they published entire dumps, very big ones. So there is one for instance, Chronicle America, which is a big newspaper, big newspaper archives in the US about 100 billion tokens, and it's all being published in open data. So we had this thing. We had also government data being published. We had also, for science, we had the chance to have the development of open science infrastructure like OpenAlex, which made it very easy to get one on all the papers around. There's about 11 millions of them. We got them all in permissible license. So, okay. So thanks to this development, has been made possible. Then afterwards, the biggest issue is not only collections, which was not that hard actually, but it was more how to process this data to make it possible to use it for trading. Because basically, we are recreating an entire ecosystem. So there is one right now based on Common Crawl. Lots of people have developed tools for that. You cannot really transfer these tools to what we have built, which is much more focused on PDF documents. That's going to be the main sources most of the time. So it's going to be PDF of reports for government, PDF of scientific articles, PDF of cultural heritage, newspapers and books. So you need to come up with a series of tools we have started to develop, which were about, okay, processing the PDF, doing OCR correction, which has been one of our main focus. And actually language models are great at this. They work fine for this. So yeah, doing all of this at scale. So it was also the purpose of this trying this corpus was also to basically create better models at processing the data. And yeah, so we made the first LLMs on this. And there are 3 of them from now on. Hopefully there will be more, but they have been released in December under free size, and they are small. So obviously for a simple reason, the fact that, okay, we are still a small labs, and we had a computer allocations thanks to Jean Zay, which is the main French cluster, but obviously it was not infinite. But beyond that, actually, I thought it was more interesting to get into this SLM space, because one of the main reasons for that is that we see a lot of interest for it in sensitive industries, mostly for issues of you want to be able to deploy locally. But then there is the issue you don't necessarily going to have the GPU or the infrastructure to do it at scale. So moving to smaller models and even designing smaller models with more multilingual support was kind of a missing niche right now. All the small models like Llama 1B, for instance, well, they're mostly talking in English. You lose a lot of linguistic capacity. So that was our main focus, and the reason we released these 3 models. And even surprisingly, and actually it's going to be one of the main focus what I'm going to present later in this presentation. Actually, even this very small one, which we call Pico, 350 million parameters, so the size of GPT-2, turns out to work really well for a variety of use cases. Now it gets really interesting when you want to be able to run things smoothly on consumer-grade GPU, or you want to run them on your own computer. So it's really a core idea even of frugality, which is also linked also with another part of regulation, which is ecology and ecological impact, and showing that, okay, you can definitely have models good enough for your tools, which are not going to be that consuming. So yeah, that was the first things I wanted to highlight first, this part about open data, which I think is critical afterwards to understand how we can move on to the next part, because I think we cannot really have discussions about factuality, we cannot have discussions about the different kind of formats we can put into the model, like semantic data, without taking these first steps of stating, okay, we want to train on open data, we want to show the entire corpus. Then afterwards, we can bring even the necessary level of trust to start discussing about more other type of issues. So the issue of actuality is obviously linked a lot with the issue of, well, just making the data available for training, obviously, once again, because if we are not releasing the data, we are not really showing whether or not it can be used effectively for many use cases. So one of the most important things for regulatory industries is what generative AI has really been about if we look back for the last 2 years. And the main thing it has been about was augmented generation. So it has been one of the leading use cases everywhere from what I've been seeing in all the things. So obvious reasons. Again, once again, the fact that these models, we don't know on what they're trained on, and usually they're not trained on the kind of content which are going to be relevant for really industry use case, because this content is not available online, not under the kind of format that they're going to be taking for command crawl. So we don't take dumps in RDF, we don't take PDFs. This is going to be the main thing that's going to be used in the industry. So it makes sense in theory because you can combine the best of two worlds, which is the flexibility of language models, the ability to parse data, make it accessible, translate it for different publics and so on, plus the kind of grounding you can bring by aligning the models with your data. The reality is unfortunately a bit more contrasted. The first thing is the fact that LLMs hallucinate a lot. And recent estimates show that, for instance, Grok, which is a Grok search actually, so it's really the search part, is actually incorrect 90% of the time. ChatGPT 50%. So, and honestly, I'm really stressful when I see people interacting with Grok, on Twitter. And most of the time, the tweet is completely wrong. And it's simply false, but people are still believing it. So I think we have a big issue right now with the kind of responsibility, irresponsibility of deploying the systems, even those are not really at all to be deployed at scale, and that are going to create a range of potential issues and trust that are going to be really hard to correct. So that's the first thing. And then there is the other big issue that relevant data isn't ready right now. And a lot of issues that have been focusing on RAG is really much about the fact that, okay, some sets are okay at first. And that's exactly our experience with the French bibliographies has been that. We had a few sets which were in XML, so all fine. And then afterward, you want to scale things up, we start to have use cases, many services, and okay, most of the time it's going to be PDF, weird JSON formats, any kind of dated standards, all these kinds of things is not ready to be ingested in a RAG system. And I think the further issue also is the fact that RAG evolves kind of independently for the language models. It has grown to become very complex. So if you see, for instance, any kind of the tutorial on LangChain and all these things, you know what I mean. So you're going to end up with a lot of workflows, a lot of errors and query formulation, and you do the reranking on stop, and you do all of these things, which is kind of not necessarily the way to go. And I'm going to talk about that later on. But I think one of the main issue is that we are using language model, but we put kind of archaic system on top, which are mostly like, rule-based system. It's not very dissimilar from the kind of expert system that's been existing for the last 50 years. And they are not automated at all. So it's a lot of, fixes and hacks and everything like that. And it's not really production ready at this point. So a very important development for RAG in production for the industry has been better grounding. And it's something which is a bit wider than that because many people have saw the need. So one of the most advanced labs on this part is Anthropic, and which makes sense because it partners a lot with public services, with a lot of scientific industries too. And they unveil this thing called citation mode, which I'm kind of surprised is not better known, honestly, because it's kind of nice what they did overall. And the core idea is really about, okay, you send the query, you send sources, and then we return to you a text, which is going to be written with citations, which are going to be attributed. So the core idea is that, okay, for each citation, you're going to know the source ID, and you're going to get an actual excerpt from the text, because that's really the key thing you want to make fast verification. So I think it's a good approach also because we worked on the similar thing for months on this thing because we met, let's say, the interest to have this kind of grounding. And I think the key issue is also to make, I think the key issue right now with language models is a bit similar with Wikipedia because, well, I've been a Wikipedia admin for long, so I know these things. Wikipedia has no authors by definition. So you cannot trust it blindly based on the fact it's reputable at all. What you need to be doing is a kind of verifiability system where, okay, you can always go back to the source. That's one of the key things. And for this thing, so yeah. So you want to have access to the sources. Sorry, I moved too fast. And what is really critical right now, it's really communication exercise, is how you can make verification smoother by making it easy for the people to check where does the information comes from. So that's what Anthropic has started to be doing, even though I'm kind of underwhelmed by what they are producing because the quotation actually they're producing can be really long. And then it gets painful when you have to go back to the information to check whether it's correct or not. So what we'll be doing, so sorry about the wall of text because the model are just being trained and it's not being put yet in an application or anything, It's the same thing. So we reuse actually the design of reference. If you are familiar with Wikipedia, you see it's going to be almost the same design for references. So there is this ref names where we put the ID of the sources, and then there is quotations. And an important thing is quotations, they can be shortened. So we used I'm not sure I have an example right there, but we used a little shortening where, okay, it can jump from one part of the citation to the other so that we can get on exactly the relevant part. That's the key thing. But exactly like we do in academic text, that's exactly what you want to reproduce. You're not going to inflict on your reader a complete page. You're going to select the parts that are going to be relevant for what you want to ground. So yeah, that's what we are mostly doing. And we have been training so specialized model for RAG. That's really the key thing. And it goes along with the general idea right now that there is even in the big labs. I think you have seen also models like deep research from OpenAI. So it's really a retraining. So it's not just a deployment. It's really about training the model to get better at search. Claude is doing the same thing for code right now for programming. The training is specifically on that. So we're going to see the specialization because we see right now it's one of the areas where we can get actually a lot of improvements, a lot of added robustness. So the approach we have been taking it for this thing actually is also very interesting for specific regulated industries. It's a new development which is adding what is being called the reasoning steps. So if you have used models like R1 or O1, you know what I mean. So in this part where the model is going to kind of draw a draft, where it's going to say, okay, so this person asked me questions. There is these sources, in the case of RAG, for instance, and okay, I'm going to think about what I'm going to say afterwards. And it turns out this approach actually, that's why actually models are not that different from humans. If you draw a draft, what you're going to write a better text. So models, the same thing. What I think is extra interesting from the perspective of regulated industries there is that we get some explainability, get some traceability. We can know exactly why, for instance, the model is writing what it's going to be writing, and you can build some kind of explainability approach around that. So what I'm showing on the side is something we have been starting to build with leveraging not only, so there is a reasoning traces, you see it right there before the answer itself. So it's going to analyze the sources, it's going to assess them and say, okay, this source discusses this and this and that, and going to disable this one and so on. That's one thing. Then what it does afterwards is it starts to write the answer, and something that has to be internally is actually a kind of mechanistic interpretability of the model itself. So there is this thing I'm going to talk afterwards in the end called the attention score, because the models are based on the concept of attention. So there is a graph of relationship between the word, the past word, what it's going to be writing. So it's going to be attending to different parts of the past text. Now, the really interesting part, when you do that, you can see, for instance, when the model is starting to quote something, it's going to attend specifically to the source, specifically to parts of things he is contemplating to cite at some point. So there are multiple ways we can improve these systems of actuality that really want to through better training, through better deployment, and we can think of all kinds of measures where we can reinforce that. Another key things we're really working on right now, again, is the issue of doing these RAG systems, but locally. And that's really a key issue right now because a lot of data, especially in the regulated sector, is sensitive by definition. And you don't want them, you don't want it out. You want it straight on premise, and you want the model to be able to interact with that. Now, the key issue, especially in Europe, is that we are kind of lacking in investments, and there are very few. I think there was something like 1% of the H100 were in Europe or something like that. So we're kind of under-equipped, at least in Europe, in terms of even GPU, especially in private sectors. So until we get that, which is maybe going to come in 2 or 3 years, we need to think about more practical solutions. And one of the most practical things is, thanks to specialization, we can downsize the model. We can make them much smaller. And then they can run relatively fast on consumer-grade GPU, like for instance a T4, which is a kind of graphic card being used by gamers for some time, so it's not really costly at all, and we can get good performance on that, so we can already deploy these things. So we made this application, which is called Scholastic AI, thanks to a grant from Mozilla Foundation, which was around that, which is the idea of, okay, we put our smallest RAG model, it's able to quote sources, so you got an idea of how it was looking like, it's able to interact with external sources from OpenAlex, and it's able to write references. Okay. Then afterwards, I think another key thing also about this RAG thing, and I'm going to end this for this part about factuality, is the fact, I think that's why it's critical to have this kind of big open source being available, not only for training, but also afterward for deployment. Because it means you kind of create also, because the issue also for inferencing over existing text is again the issue of responsibility. If you're inferencing over text under copyright, they are going to reproduce them, or maybe not, but then obviously it was potential issue of liabilities. So what we thought about actually is about how we can also better valorize common corpus also as a resource for RAG. So especially considering the fact we do have a large set of the government norms in multiple countries, a large set of scientific articles, healthcare guidelines, banking standards, all of these kinds of things. So this list I'm furnishing actually is a list of current use cases we have right now, where not only we are training models, but also we are helping a series of actors to enrich their internal data space with this kind of content, which we can provide to provenance and all these things. So yeah. So what I think factuality, again, it's really much about the data, it's about the extended data ecosystem. It's not only about training models, it's really much about how we can make them better and so on. So I'm going to end with the last part, which I think is going to be more, maybe the most technical one, but maybe also think one of the most interesting one, I think, because it's also the most experimental one, and maybe I should think to show it to you beyond the presentation here, is semantic data. So the key thing you have to know is the fact, obviously, and I'm not going to, it's going to be easy for me to convince about you, but semantic data is actually very, very important, especially in regulated industries. And it's being used a lot for data standards, data exchange, and so on. So it's absolutely critical. It's not well known enough by general audience, but it's like, there's the fact with big infrastructure, you only notice them once they stop working. It's almost like this. And typically we know, for instance, when we search something on Google, it uses a lot Wikidata under the hood to be able to disambiguate and stuff like this. But even more so, there are entire industries being powered by this kind of XML RDF things in very different sectors like banking, everything like that, which are going to be rely on these things. So that's the key thing. Now, the big issue. Models are not being trained on it right now. They're not being trained on semantic data. They don't know it. And they struggle with it. So there is a format, like a format familiarity. Another big issue is you think about, okay, maybe you can correct that at inference time. You're going to be quickly the issue of, okay, you have a lot of standards, you have a lot of properties, for instance, to give you an idea, Wikidata. If we remove all the identifiers, I think it's about 4,000 properties. It's not something that can fit really a context window. That's a key issue. So, and even if you manage to do that, the models are not going to be reminded of that really well. They're going to have a very fuzzy memory of these things, so not being deployable. So what you have concretely, and now that's a big frustrating thing because there have been this comeback of knowledge graphs throughout the past year with approach like GraphRag, where a lot of people have been seeing that, okay, when you deploy these things, and what you're going to notice very quickly that, for instance, indexations start to get very fuzzy and you're mixing up things. So you need to have more consistent presentations about the fact, okay, this text is really about this country. This text has this kind of temporal value being attached, so only valid for a specific time and so on. So you want to create some kind of constraints. And yeah, there was a lot of promise around that, a lot of very interesting evaluation made with this system. But now the big issue is how do you create that when you don't have them? Because all the evaluations that Microsoft did on our graph rack thing was on racks on graph set already existing. You don't have to create it. So yeah, right now there is this demand, there is this need right now to get models which could be able to deal with an edge graph. It's kind of frustrating because we know the models are kind of good right now at understanding text. They have this capacity, but they're not good at getting consistent outputs. They are not being memorized in any kind of standards and all of these things. So what I'm going to show to you is kind of a new thing. It's not being released yet. We're going to release it in 1 or 2 weeks, but it's part of the partnership we have made with Wikimedia Enterprise. So we have access, well, now the data is being released for everyone, obviously, but we had access to data they have been preparing based on Wikidata because, well, there was this big dump on Wikidata, but it's not really directly exploitable. And okay, we got a very nice version with all the statements being kind of clean and everything like that. So we thought about training on that. So it's a kind of prototype, and it includes right now about 20% of Wikipedia item. It may grow a bit, but now it's mostly about the time needed to process all of these things, so there's no reason not to expand on it. And what we did, and actually it's almost like a kind of proposal for discussion, actually, which I think can be interesting, especially if there are people working on RDF and all these things. We thought about, okay, how we can convert that in a way that's going to be making sense for language models. One of the main issues is that if you take the classic RDF representation, so we took the simplistic one, there is no qualifiers, all of these kinds of things, just subject, predicate, object right now. If you took that straight directly, it's possible to train on that, we tried first. And then we met quickly the issue of the fact that models don't like repetitions at all. So if you're going to repeat, for instance, here's a novel by Robert Musil, if you repeat the name each time, you're going to, first, it's going to be costly for you on inference time because you generate more tokens. And then it's also going to be a problem because the model can get stuck in loops when it's going to repeat too much. And I think you have seen that in deployment if you try to fine-tune model or anything like that. So we came up with other representations, which also leverage special tokens. So we like tokenizer at Playas. We train some of them and so on. We even made a proposition to enhance the VP tokenizer. So yeah, we think it's a great idea also because once we use special tokens like this, they are specially trained, so you get better performance. They are being really aligned for the task. But then afterwards, the core idea is kind of tacit triplet in some way, because typically the subject, we don't repeat it. And when we have objects which are concerned by the same properties, same thing, we chain them, we don't repeat them. So it's kind of continuous chain. So yeah, we got this approach right now, and I'm going to show it to you afterwards how it's going to proceed. What we did, and it's really actually at the core of actually how we trained also the RAG model, but I'm not going to talk about that. The way we are doing right now to be able to train model on this is not to train model directly on this output, because what you really want is reproduce the kind of communication settings where people are going to be using your model. So what you typically want for Wikidata is, okay, you have a text and you want to transform it into Wikidata-like statements using Wikidata properties and everything like that in a kind of very aligned way. So it's going to identify what is going to be the main topic, and then it's going to attach a series of information about it. So I'm not going to dive on this into much detail because maybe we can also discuss it later on, but the core idea about this thing, which may seem a bit complicated, is that you take the Wikidata statements as you have them, but you make them your outputs. This should be the final thing you want to predict. And before that, you're going to add up like the missing components you don't have right now. You're going to generate them through language models. So typically what you're going to create is a series of imaginary text, not existing at all, but a bit like in the reverse of what they did with Wikipedia, so they took Wikipedia text for existing, they transform it into series of representations, and you took the inverse, you start with the data representation, and you transform it into a series of texts that do not exist, taking existing text like inspirations to maintain some kind of diversity, so it can be text in diverse language, diverse kind of styles, and everything like that. And then you train directly on this pair of things. So you have the original, you have synthetic text as input, and then as output, you're going to get the data. So I'm not going to talk at length about that, but maybe it could be more interesting to go straight to the actual version. Maybe I'm going to leave the presentation. I'm going to show you the actual thing. I think it's right there. So it's going to be the first public demo of this thing. And what I'm going to be doing, so I'm going to hide the code because it's going to be a bit too much. Yeah, so I'm going to take a text like this, which maybe I'm going to enlarge a bit, which is, it's the opening summary of Tosca, the opera by Puccini on Wikipedia. I'm going to generate text with that. So the first thing to notice is that it's a very small model. We are on GPT-2 size model, it's very, very tiny. And we are on a T4, which is a very small GPU. We're going to generate text with that, so it's going to be relatively fast. And then we're going to get the answer. And so the final answer is going to be this, which is all aligned on Wikidata properties. So you got instance of, title, drawer, composer, and so on. All of these things are standardized Wikidata properties. Plus, since it has been trained on Wikidata, it has also memorized many of the items and it's kind of standardized way. So you can also reuse that for data harmonization. Some of them won't be typically like, okay, the original play being used, so it's going to be non-formalized, but still you can use that afterwards, the basis for the reconciliation. The other nice thing is really much about, okay, the fact the model has memorized properties themselves. So it's all being generated by the model itself, this kind of thinking phase, where the model is going to think, okay, it's about an opera, and then it's going to connect immediately with the kind of IDs being used by Wikidata itself. So it's going to be the drawer and everything like that. The nice thing is it's going to be making inferences even about what is not really explicit in the text. Like for instance, it's actually an Italian opera, but based on the fact the name is in Italian or the people are in Italian, okay, it's going to be an Italian opera and all these things. So you have this kind of process, which is again very similar to how someone would approach this problem manually, where we start to think in a kind of non-formal way, and then you're going to end by mapping and adding this kind of in a more structured way. And then it's going to end up like this representation in the end. So right now it's kind of, we're still finishing with a few experiments, with a few tests around that. We still have some issue repetition, which we are aiming to correct, but that's basically what we are doing. So I'm going to end on that at this point. I think the most important thing is that it's a repeatable approach. And what we're seeing now is the opportunity to expand that on other standards, especially when there are other big open set available, but maybe even when there isn't, because we can use the sensitivity data for this thing. That's one of the key things. And yeah, I'm going to end up with the last thing. One of the reasons I think it works well, and I think one of the things that surprised me why people are not being trained on semantic data is the fact that really language models, they kind of behave already like knowledge graphs in a way. And if you look inside, like what is the model processing, like the attention path from one side to another, what you're seeing is really much about the model drawing these kind of connections about these different kind of concepts. So in a kind of somewhat fuzzy way, obviously, but it's still working relatively well. So yeah, that's basically the fact that right now we are thinking that maybe it's all a graph at this point. So it's kind of fun man on Twitter last weekend, which kind of blew up. But yeah, it's I think it's really much about the fact that it can actually work well, and I think it's the only reason it didn't really happen already. Like training straight on semantic data, I think is mostly due to the fact there is a disconnect between working on generative AI and working on RDF and all these kinds of things. Okay, so I'm going to stop at this point. And I think the key thing right now, I think, which I really stress is the fact that the space in AI is open in both meanings, both in the sense that I think we're going to see much more open source in this space, but also the fact that a lot remains to be done. And even as a small labs, you can make a lot of difference in this thing because especially with everything happening right now with specialization, knowing exactly where you can go and knowing, okay, you're going to train on specific standards, we can definitely be competing with a much, much larger initiative. Thanks a lot.
Thank you. And I think we have time for a few questions. Maybe I just started to, my background is in knowledge engineering and knowledge graphs. So we could talk, I think, forever about whether knowledge graphs and large language models are knowledge bases or not. But just an observation, when you were saying that knowledge graphs repeat a lot, absolutely. And it's not just annoying for AI, it's also annoying for people. So that's why we came up with so many syntaxes for RDF. And actually, one of the main design principles for the alternative syntaxes beyond RDF XML was doing a little bit of that without the tokens, but basically avoiding some of the repetition because the main, people who really love RDF, they used to write it by hand. So yeah, so something like turtle or N3. Trip a little bit about that repetition, that verbosity as well. But just as a sort of historical fact by now, because they're quite old. Okay, so we received quite a few questions, so I'm going to try to go through all of them as quickly as possible. So starting perhaps with something that you've addressed earlier in your presentation, could you explain what the concepts data coherence and data toxicity are and how they negatively affect models and the people that use them?
Okay, so toxicity is right now, it's a situation again with links with transparency because obviously now the big labs, they have a responsibility to ensuring that the model are going to be okay in terms of not outputting any kind of, for instance, sexist, racist, or anything like this. That's one thing. But what they're doing right now, they are doing this thing in a phase of post-training. So at the end. And if you look at the base model output, like for instance, the open ones, obviously, because we don't have them from OpenAI, but like if you look at the Mistral, for instance, output straight, it can definitely output very terrible things. And that's the one thing. What we have been doing right now, which is kind of a different approach, which I think mixes up well with the approach of pre-training in the open, is that we made this filtering straight from the pre-training data at scale. So we developed this kind of filter, which is being called Celadon, because we were lacking also the tools for this, because right now there are very few. It's kind of astonishing, even classifiers and all these kinds of things are being underdeveloped, and there was no good classifier for toxicity in multilingual. So we had to train it, we had to publish it, and so on. I could put the reference publication for this. And yeah, this is something we deployed at scale, and we made some internal evaluations afterward of our models for toxicity and everything. And it turns out even the base model are extremely mild, and which is kind of good for the kind of public we are targeting right now. So it makes sense to have this kind of featuring radical one.
Yeah, I'm gonna move us on to the next question so that I can see there's more and more coming up. How do you bring your models and experiments to the deployers to users in regulated industries and regulators themselves to make the case that you're meeting their needs? So what has been the feedback so far? What sort of interactions
I
did you
think
have?
the feedback has been really good. And what has been striking is the fact, again, we are a very small lab, so we don't even have time to reach out to people. So we are being reached by people in the industry,
Yeah.
banks and so on, and also people in the media also, which are really concerned. I just today had a big meeting with a lot of people working in French media and so on. And okay, so it's a nice thing. Now, what is more complicated from our side, again, we are a small team, is the fact that dealing with regulated industries means also dealing with time, and you need a lot of time to approach and build trust and everything like this. So I think it's more of a challenge that we have right now. The final thing, obviously, is the issue of infrastructure. So I think one of the critical things for us will be to partner also with providers, especially safe ones. So we have been starting to discuss with Outscale, for instance, which is a big reference providers being used a lot by regulated industry in France and Europe. Because they lack the infrastructure at some point to run things.
But it sounds like aside from the issues that you mentioned with the size of the team and so on, that there is a lot of interest in
definitely, especially after the AI Act and everything. So people are, but plus the fact we are 2 years after ChatGPT, so we are beyond folks, and people start thinking, okay, maybe I want to plug that in my infrastructure. How do I do that?
Yeah, exactly. Okay, so the next question we received talks about chain of thought and chain of thought reasoning, and the question is, how do you or how would you train chain of thought into your models while keeping Playas principles around openness, factuality, and grounding in primary sources of information?
Okay, so what we're doing right now, and I should actually showed with Wikidata, what we're doing is like structured reasoning, actually. And it's different from what they have been doing. Actually, it's really fascinating what they've been doing with R1 because it's been an open reproduction of O1, so from DeepSeek. And what they have been training straight the base model. So they just put a reinforcement learning approach. Actually, it's R0, not R1. But they just put this idea of, okay, we have math problems. We're going to let the model think by itself, the base model. And it's going to think by itself, and at some point it's going to find a solution. What was really interesting is the fact it's completely unstructured reasoning. Sometimes it goes back from English to Chinese and so on. So it's really kind of
Interesting.
So I think it's really super interesting from a scientific perspective. Less so for the perspective of users that maybe want actually to reuse the reasoning for explainability, which I think is something we're looking forward to. So that's why we have this kind of multiple steps build up within the model. I think it works great with small models because they need to be guided in a way, It's so what you are seeing with Wikidata is the fact, okay, there is kind of free-floating thinking, then there is this kind of structured thinking. We have done the same for RAG. We have first an examination of the queries and the sources, an actual draft of the answer. And yeah, I think that's the best, but it's still very new, all of these things. So I think the solutions are going to emerge.
Thank you. I'm going to take a step back now and move us on to a few other topics. The next question is about GDPR and the degree to which GDPR is being revised. As far as I know, the European Commission is considering revising GDPR anyway, whether triggered by AI or not. But the question addresses something really important, and the fact that the relationship between GDPR and generative AI and foundational models. So what do you think? How do you think, in your opinion and your work, how do you think GDPR, as it is right now, impacts on the tech scene, on the AI scene?
Yeah, so I think one of the key things with GDPR is, well, I'm not perfectly also thinking that the current approach is fine. I think it's too
Mm-hmm.
complicated and there's too many.
Mm-hmm.
But general principle is really popular in Europe, and people are
Mm-hmm.
really care about protection of data, and it's something which is
Mm-hmm.
going to
Mm-hmm.
remain. So what we believe right now in the way we have been approaching this issue, most of the content we have, since it's curation based,
Yeah.
is already exempt from this kind of issue. So it's mostly
Mm-hmm.
public domain. Where we had to actually implement filters was because we created this kind of administrative command crawl for French and European sources and open data.
Mm-hmm.
We use
Mm-hmm.
much more expensive approach still on websites, obviously administrative. But to give you an example, there was this issue where we had these forums where people talking about their drugs problems. And
Mm-hmm.
they were under pseudonym, but they were talking a lot about their lives and about very intimate things. So
Mm-hmm.
got this
Mm-hmm.
thing, but it gives actually the idea of training models for GDPR featuring in
Mm-hmm.
kind of way, because right now the models are kind of unsatisfying. You have Presidio from Microsoft, for instance, but what they only
Yeah.
do is removal of the
Yeah.
person names. And
Yeah.
sometimes they are overzealous about that. They're going
Yeah.
to remove
Yeah.
it even when, okay, it's surely a public person or it's very old data. So what
Yeah.
we want to do is to implement this kind of reasoning approach you have seen before within this kind of intelligent GDPR removal, which could do this kind of two-pronged thing. Okay, it's going to assess the fact it's actually a well-known person, so it's okay. Or conversely, it's going to assess the fact even though the person is not named, there's still a lot of critical information associated with that, and it's a
Yeah.
non-public person, so maybe this thing should be dropped. And
Mm-hmm.
I think right now, yeah, I think I can also be a tool for these things, and I'm kind of hoping also it can also help making kind of ambitious regulations more easy and
Mm-hmm.
ensuring that, okay, fundamental rights are being respected.
Thank you. Thank you very much. There's two questions that have to do more with how RAG and other techniques work. So one of them says, what's the minimum amount of data you need to train a model for it to actually have high performance and generalize well to client questions? So, which can be really anything. You can't really predict them, but they will be fairly similar according to the question. And a bit on the relationship between fine tuning and RAG and when would you use what?
Okay, so right now we are training for RAG. So I know there has been this opposition between fine-tuning and RAG for a very long time. I think the key thing is that fine-tuning should never be about memorization because it's not great at that. And it should be really about task, how you model the task and so on. And RAG is a task. Source quoting is a task and so on.
So
So
what you are using the
yeah,
AI for? Yeah.
exactly. What are
Mm-hmm.
you using it for? What kind of output you want? How do you want it to be structured? And all these things, this is really much a task. And then afterwards, the model should be agnostic in regard to the kind of knowledge that's going to be processed, even though there can be concern about, okay, if it's really out of distribution, it cannot work so well, but that's a key thing. So what we're doing right now is a bit different because we are doing this thing which is in the industry now is being called mid-training. So you know there is pre-training, there is post-training, and now mid-training is really much about, okay, uh, kind of specializing the model, but still on a lot of data. That's what we're doing
Mm-hmm.
right now. So for the RAG
Mm-hmm.
model, we train them on 45 billion tokens.
Mm-hmm.
So it's not pre-trainings, it's
Yeah.
much smaller still, but it's still big. And
Yeah.
it's made possible thanks to synthetic data. So we can have plus thanks to Common Campus because we have these big sets of very varied text, a lot of text with some kind of data issue, so it's
Mm-hmm.
great, this thing. It's kind of nice actually because it means you really need to anticipate diversity when you do these kinds of things. You anticipate, okay, you want to have all these languages, all these domains straight into the model itself so that it can work out of the box in many cases or be kind of lightly adapted afterwards.
Mm-hmm. A question that just came in right now. So for a conversational agent, is it better to fine tune on question answer pairs where the answers are generated by people? Or is it better than answers from larger models or distillation data? So
Yeah,
your
I,
opinions on
I,
that?
yeah, no, I think I talked a bit. I think distillation is a bit of a misnomer because what
Yeah.
we're doing now with synthetic data is more advanced than that. And in
Mhm.
many cases, we are doing better than large models because we are kind of reversing, chain of predictions. We're taking,
Mhm.
generating the input, to predict induction output. I think optimization is the same thing, actually. I think the best approach are really about finding quality text that you want to have the model looking like in terms of styles, in terms of structure, and all of these things. And then create the input that does not exist yet based on what user queries should be looking like. And then you get the models to actually look like the final output. And yeah, that's most of what we're doing right now. And I think it makes a lot of sense, especially for regulated industry context, because format is super important. And you want typically to predict XML, you want to predict all these kinds of things.
Excellent. One final question. I'm not going to be able to go through all of them. I apologize, but maybe we are able to reply to provide all the answers in written form. But I just wanted to move us again away to a more general topic, which I think summarizes the approach that players or the ethos of players very well. So someone is asking, how can someone practically support the open source AI movement, and how do you convince people about the power of open source when there's so much noise and a lot of energy spent by corporations and big tech in enticing them to use their products? So, and is there a positive loop? So does more openness encourage more openness? Maybe we end on open source AI.
Yeah, well, that's my hope. What I'm confident is that I'm seeing right now the same factors that have been driving the rise of free software 20 years ago. I'm seeing in this AI right now. And the main reasons that at some points, when you want to really build things into the infrastructure, at some points, you need to have a kind of auditability into the system. That's really the key thing. The reason that everything is running on Debian right now for all this big infra and so on. So I'm kind of hopeful it's going to be the same approach in AI right now. Now, I'm not going to be saying it's easy. And I think one of the hardest parts, if you want to start on this path, is that right now there are very little venue for even fundraising. That's the main issue. And a lot of people are, exactly as you described, they are being convinced by large labs that this kind of open approach have basically no future. Everyone is going to come to OpenAI because they are the best. And it's kind of, it's much easier, I would say, on the business side, because we're seeing people now 2 years after trying to be doing all these kinds of things and fixing all the kind of data issues we have been talking about today, and seeing the limitations of the system in concrete. But the reality is that a lot of people, in the more investing ecosystems are not really aware of this reality yet. So they are still being immersed in the kind of preconditions. But yeah.
Thank you. Thank you. I think these are important thoughts to end on. Let's thank our speaker. And before I wrap up, let me just remind you that this is part of our data-centric AI program of research, policy, and advocacy at the Open Data Institute, where we want to advance our collective thinking on the socio-technical data infrastructure of AI. Just like Pierre, we're convinced, and we have 12 years of experience to in lots of case studies to prove it, that open, healthy ecosystems in technology go a really, really long way. But at the same time, as you were saying, you can't expect them to emerge out of nothing. Sometimes they do, like in Wikipedia, but replicating that sort of success is quite difficult and requires funding and deliberate action. Here on the right-hand side, also a pointer to some of our recent work in AI data transparency, where having the sort of resources that Pierre presented today would go really a really long way, not just for me as a researcher, but also for developers, policymakers, and the media, who is very important in influencing how the public sees AI. Our next webinar is in around a month, just after Easter. We are going to talk about data workers. You are a hidden resource in AI, doing a lot of essential work in creating, for instance, fine-tuning data sets for safety, but also creating and curating data and providing feedback to models. Our next speaker is going to be Dr. Saif Savage from Northeastern University in the US, speaking about the research and advocacy work she's been doing towards collective action for a data worker-centric future. I hope to see you all there. And with that, thank you very much for joining and for the questions. Thank you, Pierre, again for being here with us. We're gonna try to provide answers to the questions that we haven't addressed. And I know some people were asking questions about some of the sources and work that you have cited in the slide. But thank you very much for this afternoon, and I hope to see you soon in a month or so. Bye-bye.
Thanks a lot. Bye-bye.
Bye-bye.